What's up, YouTube? So this is Corey. First devlog. I'm going to try and do these daily. Basically, we're going to be going over just how I program BitFire every day. We'll be doing today, I've got Apache and Nginx access logs parsing. So we're going to be writing some code to process the access logs. This is going to allow us to look at the past data and be able to build custom filters and rules for the firewall before we run it at all. And then this should prevent false positives and give us a really good baseline for where to tune everything. What I'm trying to build is a one-click configuration button, so that way we don't have to have people go in and try and read all these configuration settings and figure out, oh, do I want this, do I not want this? We've built that right now in the current version of the product, which is great for the power users, which you need to have that to support them. But most people aren't power users, right? 98% of the people are not power users, and so now we're building the feature set for those people, so they can just come in, install the software, turn it on, and they're good to go. So in order to do that, we need to be able to look at the data. So we want to be able to look at the historical trend data or the historical access log data and make sure that the settings we're going to enable are going to be compatible with their website. So, again, aligning my hat is always weird in the video because it's backwards. So we have a couple little things set up here. We've got a unit test framework here. So this is our test suite, and this is our server code. So this is not part of the mainline branch, but this is code that runs in the back end. And I'm just going to kind of show you guys like how I go about solving these problems and how I go about writing the code. So we have some code here to return a list of all possible locations for configuration files for Nginx or Apache. I've covered Mac, some older HTTP locations, Apache. I used to be a big FreeBSD guy, so I always look in user local. I always install everything in user local. But for most Linux systems, it's going to be etc Nginx conf or etc Apache or Apache 2 conf. So we cover those in there. After that, we take these glob patterns and we convert them into a list. So I really like a functional style programming. I think this is really clean. I'm programming for PHP 7.1, right? That's the target. So unfortunately, can't use some of the new cooler features in PHP 8. Like there's a nicer syntax for this. We don't have to type out function. It just makes it look, these anonymous functions just look a lot cleaner. But basically, we're just going to reduce all these patterns by this function. And then we're going to take this pattern and we're going to glob it, and then we're going to reduce that list and basically just append it to this carry flag, right? So we're going to take whatever comes back from the glob, we're going to append that to the list, and we're going to return the list, and then we're going to look at the next one and the next one and the next one. Once we're done with that directory, then we go on to the next directory from the outer loop. So there's two loops here because we're looking at all the different configuration files, and inside the configuration files, we're looking at all the different files inside that directory. So we have some tests here that we can run to make sure those work. Let me just kind of run the tests that we wrote here just a minute ago so you guys can see what that looks like. Oh, we don't have code coverage because I'm not using PHP debug. And we got a syntax error. Oh, right here. Let's just return, we're going to go ahead and return an array of an empty line for that guy. So here's our two tests. We test configuration globbing and we test get all confs. So I'll just show you real quick what this looks like. We have this function, get server config file list, that's this guy, which just returns this array. Then we pass it to the pattern to list, which is this guy right here, and that returns the result. And then we just make sure that we have a result in there. So if you want to see what that looks like, right, we can return that. We can say that returns an array, and I'm pretty sure tiny test can print that out for us. Yeah, or verbose, yeah, we have an array. If I do 2 V's, nope. Let's do, we can echo it though. And yeah, here's our output. This is the console output from the test. And it found these 4 different configuration files in my system. So it's working correctly. Here we have test get all consts. This is basically just shorthand for this one line. I didn't think I wanted to remember all these different functions and how to chain them together, so excuse me. So I just have a function here that does all of it. Get a list of all HTTP configuration files on the target system. So expand this a little bit. Alright, so now that we have the configuration files, there's a couple steps we have to do. We got to look for all of the HTTP configuration files. We have to look for where all the access logs could be. Then we have to process the access logs. And then we have to look at each line, convert that into our structure, which is a BitFire request object, send that into the firewall, and then have the firewall, we're going to need to add a new mode that allows it to look at the output of that. Instead of blocking, right, we want to toggle that to allow, right? Toggle that to allow whatever that block would have been, and then add that to the configuration, right? So we'll basically start with everything on, then we're going to run all of the config files, then we'll add anything we find looking at the HTTP files to an exception list, or we'll just turn off a feature completely. So if we see we're just having all tons of false positives, we just turn the feature off. Otherwise, we'll add it to a list of exceptions. So, yeah. Currently I don't see any problems with this approach. But yeah, we'll know once we run this on some of our test systems, how it's going to work. So let's take a look at what process access line looks like, right? So we create a new request. So let me back up a bit. The way I like to break this problem up is we're going to do it in reverse order, right? So I'm going to process one line of an access log file, and I'm going to send that to the request. That's it. Then from there, we'll unroll that into something that can open the configuration file and send us one line at a time. And then after that, we're going to add another function that can open up a configuration file and return us a list of all of the access log files. And then we already have the function that finds all the configuration files, right? So we're kind of working the problem backwards now, right? So we want to do just one line at a time. So let's get a test file, right? A test line. Var log nginx access log. Oh. Do I even have a web server on here? What have we got? Oh, there's one. Okay. Access log.1. Let's take a look at what's in this guy. Yeah, okay. Here's some things. Let's just see what the format is. So set no number. And we're going to copy one of these guys. And we'll paste it here in our list of test cases. Alright. And we'll have to change the quoting pattern here. There we go. So we can process a single access line. So this line right here, right, this is kind of like PHP unit. We can annotate with a data provider, and then that'll call this function, access log lines, and we'll call our test function once for every entry, right? So we have a string, which is a line, and we're going to call process. Oh, it's BitFire. If I could type right. BitFire server process access line. Let's just get the result of that, and we're going to print that result. So, let's do let's take a look at this guy. Now we're going to change our command line here a little bit. We don't need those, and we're going to call just the one function, test process access line. Well, that did something weird. We got a syntax error or something. Uncaught type dynamic specs parameter 1. Oh. We called it wrong. I should really add that to be a better error message, right? So we want to run just this one test in this one file. That's not a file. So, okay, here we go. Here's our BitFire request, and here's what we were really looking for, right? This print R right here is this call to process as a CSV file on our input line. And here we have all of our constituent parts, right? The reason I use getCSV is because getCSV knows how to process double quotation marks and process whatever's in it. So because the access log files are space separated and they have quotes to encompass things that have spaces in them, I don't want to write this function. It already exists inside PHP, so we just use that. So let's see. Let's say BitFire request. I believe this has a constructor. Nope, just a bunch of public accessors. Okay, perfect. So let's do $R agent equals parts 9. Now this is a default access log, and I realize you can have custom access logs. I'll see where this goes. We're going to need to handle the case where people have a custom access log. At least we should fail gracefully. And I think for people who have custom access logs, you know, this feature is not really designed for them. They can use the advanced interface. This is for people who have just sort of a generic default install, want to click the go button, auto configure. So I don't think for this iteration we need to necessarily worry about that. So let's get the URL. Oh, we need to, well, we don't have just the raw URL. We're going to need to parse the URL. So URL parse, is it? Is it parse URL? Parse URL, parse. Yeah, parse URL, cool. And it looks like that is 8. Parameter 8. So let's say URL equals, and then headers. We don't have access to the headers, unfortunately. Do we have access to the... Oh no, 8 is the refer, 5 is the URL. Okay, 5. Let's do the refer then. We have a refer equals parts 8 R post. Unfortunately, we don't have post data. We can say method. Let's do method. Now here's another problem. Here we have this is, yeah, and we need to get rid of this guy too, don't we? So we need to space separate on part 5. All right, so let's say $URL pieces. I don't know. We already have parts. Say URL parts equals explode. I really don't like that name. We're gonna explode on space, and we're gonna pass it parts 5. And then now we can say URL parts. Oh, what's going on here? I really love this and Pro 2 keyboard. I love the size, but occasionally I put it in a weird mode, and that is the only thing I dislike about this. Okay, so URL parts, this is URL part 0, this is URL part 1, so we have URL part 1. Method equals URL parts 0, that's going to get us the get right here. Do we have a result? I don't think we have that. Should we process 404? We shouldn't process 404s, right? We should not process 404s because 404s is not a valid request on the web server. So if someone requests some bullshit, we shouldn't add it. We should only be adding 200s. This leads in, it's an interesting thing. What if someone 302s to a 404 page? We wouldn't even see that on here, right? We don't see where the redirection goes to. But I would say anything less than a 400, right? If it's a 300 with a location redirect or a 200 status code, then we should, if it's not a 404 or a 403 or a 401 or a 500, it should be some type of valid request that the web server can handle. So we should add it to our list. So let's just add in a configuration here where we say if parts 6, right? If parts 6 is greater than 399, then return R. Actually, I don't know if we're even gonna. What we should be generating out of this line is not a BitFire request, right? Well, yeah, we should turn the line into a request, and then so that'll be this function that'll just turn it into a request. Then we'll take the request and we'll process it. That'll turn it into an exception. We'll add the exception to the exception list. Okay, that's a decent strategy. URL parts explode. Okay, so we've got our conditional here. Then we're blowing up the URL. Right? We're blowing up the URL here. We process that, and then we're going to say path equals URL parts. And I just know this off the top of my head, but let's go ahead and let's pull up over here URL, parse URL. You guys can't see it on the other system here, but I'm going to the PHP documentation to look at what all the parts are that it returns. So it returns a path. We have a scheme, which potentially that could be returned in here. Do we have a port number? Nope, no port number. We have host, which is, that's the refer. We don't have any host information in here, which I feel like it's got to be one of these fields. I think our access log, maybe because this is a default access log, we need to put that on there. So host equals, we'll just call it default. What else we got? Port, user, path. We already did path, query. I wonder if we have another function which is going to process, let's see, where is it? Process, where's that guy? It's like process line, which processes this raw server data and turns it into the BitFire request, which the rest of the system can process. So serve dashboard. Okay, so request. Oh, that's the thing that's done in the constructor. Cache behind. Where's that constructor? Construct. Boom, boom, boom. Yeah, process request 2. That takes. Okay, get variables. So this takes all the global variables. Well, We can put in the server headers. We can put in the server request variables, or the server refers. We don't have access to the cookie data. We don't have access to the post data. We could process out the get parameters. And then just pass it to process request and let that create it for us. I kind of like that better because that's going to leverage our existing code. Let's get rid of these guys. That's going to leverage our existing code, right? So we're going to be using more existing code. So maybe we should actually change this to, right, so this guy we can say R equals process request. And then from here, we just need to process out post is empty, right? So this is going to be an empty array. Cookie's empty because we don't log cookie data in the access log, so that'll be an empty array. Server is going to be an array of, I think it's HTTP referer equals parts 8. And then, we need the path too, don't we? Yeah, that's right. The server array has the, what's in there? PHP server variables. Server variables, what do we get? Self server address. So what we want to do is we're going to fake out the get array and the server array. We're going to pass it to this function that we already have in the main code line, which processes those global PHP arrays into a request object that we can then process. So first let's create the server array. So we're just going to create a new array, and let's take a look at what we've got. We have server adder, which is equal to server address is equal to this line right here, right? That's the remote address. So that's parts 0. We still need to return, let's just return, can we return null? No, I can't. Can I also get a type error? New BitFire request. There we go. Boom, let's see if this doesn't segfault. Blah, blew up. Exception on the data set. Do test, and where did it run? It blew up. Server line 56. Parser. Oh, did I spell it wrong? Parse underbar stir. Oh. Oh, this is awful. This is awful. Okay. Okay, you, instead of returning the result, instead of turning a result, it parses them into this parameter. Oh, God. Oh, PHP, you kill me. Okay, so here we go. Here's our, sweet. Okay, so we have processed our, we're sort of reversing the process of our access console log, going back into our constituent PHP global variables, right? We have a server address request method. Here we got the query string, we got the refer, user agent, here's the actual URI. Then, sweet, here's our get parameters, right? And then here is the resulting object. So now we can just do like this, and then we can do this, and let's $R, let's print that guy, run our test, and it explodes spectacularly. Line 59. What's the problem here? Oh, wrong namespace. BitFire. Boom. Sweet. And now we have something that we can process by the actual firewall, right? So process an access line into request object, right? So this has one function. We pass it a line and it returns a request object. It passes a access log line and it returns a BitFire request object which the firewall can process. So let's run our test again, and we have this guy which we need to get rid of. And this should say, let's assert that get count. So assert GT. The actual is count. Excuse me. Count R get. No. Yeah, get is greater than a 1. Unable to process get params. And we run that. Okay. Sweet. How fast is that? Could be a little bit faster, right? We're looking at 2 micros. I always want it to be faster. It's never fast enough. So let's URI see. Access URL method and access URL URI. We don't actually use the protocol, right? But we do use the URL in 2 places. Boom, we have removed all magic numbers except for this one, which, I don't know, maybe that should be a configuration item. I feel like it's probably fine being hard-coded because we really don't want to be analyzing 404s, 500s, things like that. Like, that's not stuff we want to be processing. Sweet. So we're sort of coming in at this from both sides. We're going through all of the HTTP configuration files, looking for all the locations. We still need to process those and look for all the access logs. We're coming at it from the other side where we're processing a single access line and we're turning it into request object that we can process. Now we need to look at every single access line inside the access log. So I have a file in TinyTest. Already has this function. So I hate copying and pasting, but I hate dependencies even more. TinyTest. TinyTest. Line at a time, right there. Kill that guy. And we have this function now for line at a time, and I'm gonna go ahead and I'm gonna expand this out a little bit. I think for TinyTest it was nice to have these kind of like all rolled up because TinyTest is a single file. But BitFire is a little bit larger project, and so we can use a couple more. We can go ahead and use a couple more lines. It's not really a big deal. However, do we... Yeah. Let's yield I with trim. Yeah, so we'll have a key value pair, which is the line number. And you know what, actually? We don't care about the line number. We can simplify this and just return the trimmed line value. And yeah, we don't need to create a line. We don't need a line number. Boom. It's even easier. Look at that. So tiny. Return a single line from a file at a time. Now, because we're yielding this line, right? We don't have to open the entire file and pull it into memory. We only have to process one file at a time. This is like such a huge benefit. So if we're processing a 100 megabyte access log file and we try and pull that whole thing into memory, that's going to consume a lot of memory. Especially if we try and pull that in an array, because right, the array sizes are not going to be exactly on the byte lengths, plus there's overhead for the array objects. So yeah. This way we can process one line at a time. This is going to keep our memory usage really low, like probably, you know, sub 1 megabyte. So I don't know if you guys have used any other firewalls. WordFence, I'm looking at you. That requires hundreds of megabytes just to process a request. Yeah, this is not efficient code by any stretch of the imagination. All right, sweet. So now we can say a function. So I guess, you know, just a quick note. I haven't talked about it in this video at all, but my style is very functional, right? So I don't create classes very often because, and I'll tell you why. I should do a whole video on this. I'll probably do this as my next video, in fact. The problem with classes is they lead to state. And state will kill you. State creates the worst bugs, the most difficult to track down problems. And just because you have a class on it, I'm an older programmer. I'm almost in my 40s now, and I've been programming since I was a teenager. Since an object can encapsulate your state, but it does nothing to reduce the amount of state that you have, right? People have classes, I've seen classes with 10, 20, 30, 50 member variables on the class. This class has tons of bugs in it. I don't need to know anything else about it other than it has 30 member variables. There's going to be bugs. So, I attempt to eliminate state from my programs as much as possible, wherever possible. This is a reason why I just use pure functions. And we use namespaces to keep everything nice and isolated and kind of, so we don't have this one big cluttered up namespace. It makes it easy for us to find things. But this encourages us to write really small, compact, tight functions that do one thing at a time, and then we compose them into a broader piece that does our overall operation or process that we want to do. So now we're going to have a function, we'll call it process access file, and that'll take a string, which is the file name. And I'm not sure what I want it to return yet, so we'll say line at a time, and the file is file name. Now, I really hate for loops, but this is kind of PHP sort of designed like this. So for each as $line process access line, and we're going to say request equals, and let's add a comment here, process an access file. So what do we want out of this access file? Well, we first need to turn each access line into an exception, right? Then we're going to need to flatten those exceptions, and then we're going to need to save those exceptions to disk. Process an access file. So that gives us a request, process an access file. So I guess this should produce a list of exceptions, which I don't think I even have a function for exception. I think it's just an array. We don't have a class. So I guess that's going to have to return an array. I don't really like that, but exceptions equals array. I really also don't like this for each. I would rather say exceptions equals and just say line at a time, call this function. So maybe we should do like, oh, you know what would be good? You know what would be really good? Let's do this. Array reduce, and our input is, oh yeah, here we go. Line at a time, right? That's our input, and then we have a function which takes simply a line, right? That gets processed into a request, right? And then we say request. So we just need a function that goes from a request into an exception. So let's say, you know what? We have BitFire, pure BitFire. We have inspect, right? Normally we call inspect. This class needs a little more cleanup. We call inspect, that returns a maybe, right? And that maybe is going to be maybe a block. So, okay. So let's do this. Let's say we have a request, right? Then we have a BitFire object. Oh man, oh God. So this is where architecture comes back, right? So we're creating the request in the constructor of the BitFire object, right? And there's not a lot of objects, but we do have a couple, right? And we do have a couple member variables, which, you know, this is, we want to get this number to 0, right? I hate these, but this is kind of the biggest object that we have inside BitFire that's not a purely state class, right? A class that just has member variables that represent state. The reason you do that is because a class with member variables that represent state has both faster access time to those member variables and it takes up less memory. So if you're going to have if you want to store something that's just state, right, like a request object or something, this is faster, both faster access and smaller memory if you turn it into just a dumb object with, I use public member variables because I don't need getters and setters. You could do, say, no, if you made them particular, you know, it'd be nice to make them immutable, right, where you can pass them in the constructor and then they're accessible, but I don't know if that's actually possible with PHP. I'd have to think about that without creating accessors. But then if you use an accessor, now you're making a function call which has function overhead, so I have to think about that. Okay, so here's where it's going to bite us. When we call construct, that's creating the request object. Oh, you know what? What is the access on this guy? Oh, it's public. I don't really like that, but if we create a new, here's the problem that I'm alluding to. I don't want to create a new BitFire object to process every line, right? This is going to consume way too much memory. We want one BitFire object, and we just inject these request objects as we create them, and then we process them, create the exceptions. So actually, you know what? This could work great. Okay, so process access file. We need a new BitFire. So let's say BitFire equals new BitFire. What is it? BitFire? Is it BitFire? BitFire? Yeah, BitFire. BitFire, right? New, and we need to go back to the global namespace. BitFire. BitFire. Now, what's that going to do? That's going to call our constructor, and we're going to process request on these global variables, which won't exist. They won't exist on the unit test. They will exist if called from the web page, which unfortunately we need to support, but I think it's not a problem because it'll be called with parameters that are just, you know, nothing that would be blocked. So what that means is we can take this and we can say BitFire request equals, oh, we don't even need to, we just assign it here. BitFire request equals process access line. BitFire inspect. And then this gives us a maybe. Maybe it's blocked. Maybe it wasn't blocked. Oh wait, we just say maybe block. I've been doing too much C++. We don't have to define the type. Maybe block equals inspect. So now we say if that's a block, then we add a new exception. Now, I don't even remember what the exception format looks like. It's honestly been about it's been a couple months since I've looked at it. It's just an array, which I knew that. But what's in there? This is really where I could use additional, this is where I really could use additional documentation on this project. But we'll get to it later. Filter block exceptions. Filter block exceptions, which takes an exception list, which does an array reduce on match block exception with a block. Let's take a look at that guy. Oh yeah, it's over here in BitFire Pure, of course. Match block exceptions. Oh, sweet. Returns block. Let's go back here. Returns block if it doesn't match the exception. So it takes a block and a list of exceptions. What is a block? Oh, hey, here we go. Okay. We have a little immutable class here, or what should be immutable. Code. Okay. Parameter. Okay. Value. Okay. Pattern. Okay. So we need to go in. I need to add these exceptions. Match block exception. Exception. Which returns a block. Returns block if it doesn't match the block exception. Oh, okay. Okay. So we pass it a list of exceptions, and then the block has already been created, right? So we need to say if this block matches any of the exceptions. So match block exception. So oh god, for each we're gonna decompose this later. Okay, so if the block code triple equals exception. Now this is just an array, but what I think we need to do is we should make an exception object, right? I mean, what did we just say, right? They're a little bit smaller. So we should be able to have an exception for codes. Pattern, we need URL, right? I don't need block time, but I do need URL, right? So we can make an exception based on a URL, a parameter, and a block code, right? I don't think we need pattern, or we can also put it on a value. No, let's just make it really simple. We have a code, a parameter, and a URL equals URL, code, parameter, URL. Boom. Okay, there we go. And this comment doesn't mean anything. Sweet. Now we have a immutable exception class, which really isn't immutable because we'd have to make public getter variables, which we don't want to do because it's slightly slower, so we're just not going to mutate it. You know, some of these things can just be solved with convention. If you just take a convention and just stick with it, what's to say that that's wrong? Now, if you have 50 programmers in your organization and people coming and going all the time on a project, this could be an issue. They say, oh, it's public, that means I can access it, change it. But really, you shouldn't have programmers trying to mutate state anyways, right? I mean, this should be like, if you're trying to mutate state, this is an idea that you're really going down the wrong way. All right, sweet. What have we got here? So now we're going to let's take a single exception, right? Boom, so we can get rid of this guy. And let's say if block, oh, we don't have a URL though, do we? Ooh, the block doesn't have the URL, right? And we're going to need that for the exception. So match block. Let's do a global search here. Boom, I don't want to run. No, I don't want to run. There we go. Match block exception, which is called from here. Okay, cool. Get rid of that. Get rid of that. Match block exception. Slide this guy over. Which takes an array of exceptions. Array reduce the exceptions. Okay, and it's going to return the block, or it returns false, right? If this returns false, then it won't block, right? Because the maybe block, right? This returns a maybe. The maybe will be empty. Boom, boom. Okay, sweet. I should do a video talking about maybes. I've done a couple of them on other channels that ended up dying. I really should do a thing talking about PHP maybes. A topic for another video. Man, I got so much to talk about. This is all I do. This is all I do, is write code. You can see it's starting to get dark now. Oh man. I really need to get a life, but the pandemic in 2020 has really, man, it's just really kind of made everything like, I don't know. Okay, maybe block. That gives me a block, right? All right. So filter block exception should return a maybe. If we get a match, we're passing in only a block. And who's calling filter block exceptions? Exceptions, there's the function. Who's calling it? This guy. When we call new block, which is a public static function on the class, I guess that's fine. But that does mean we have access to a few things because it's on. Yeah, we have a static instance. Oh, I should be calling get instance, shouldn't I? Oh yeah. Okay, let's go back to the. Let's go fix that real quick. We shouldn't be newing up one. We should be BitFire get instance block. Yeah, let's just let that manage it for us. Okay, where the hell were we? I lost my place here. Okay, so we have the new block. Now this needs to pipe the URL into this call, right? Because we need to know what URL this block is for. I don't like just adding it on the block. Where the hell is it passed from? Let's see. Or is it already on a member variable? That's what I'd prefer. So we already have the request. And we know it's on the request. So yeah, let's just pass that in. Let's just say this request and path, right? Yeah, path. Oh, what about the host? Okay, so here's another issue. Because PHP could be running the firewall from the PHP INI, and we could have multiple host configurations, we need to know. Okay, filter block exceptions. We need to know so that we're for the host and the URL, right? Because URL on host A, we need both host and path. Might be one thing. URL on host B might be something different, right? They could have different exceptions. If we look at the exception, so there should be an exception, right? Self exceptions, yeah, that's static. I really don't like that. I wish we could define generics in PHP. Or if you're C++, type defs. What do we call it in C++? Templates. Okay, so we're going to pass in this unique string, which is going to be this request host concatenated with. Is there a PHP concat function? No. Kind of don't like doing this, but. So we go click on this guy, and now we're going to add. Yeah. Now we're going to add a string for the URL. Ah, but now we're array reducing. Okay, let's do this. Let's say, let's do partial TF partial right. Okay, so if you guys have never seen this, we're doing partial application programming here. So what I've just done, matcher. Okay. This might look confusing to you. We're passing in the URL for the block and the exception, right? Now we want to array reduce on our exceptions and our block, right? So this is what we're starting with, is the block. We're passing in the list of exceptions, right? This is what the array that we're going to reduce on. This is the callback to do the reduction on, right? Which is our match block exception, okay? But our match block exception now has this third parameter, right? This URL, which, oh, I did this wrong. Match block exception, filter block exception, match block exception. Yeah, this guy right here. What is going on with my code completion here? Do I have 2 BitFire pures in here? Oh, yeah, okay, shit. Boom, 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 boom. BitFire pure, we want this one. Let's look at this guy. Yeah, I was editing the wrong file, so let's close that. And we have URL. Okay, sweet. So, right, what is, now if we look at this, match block exception, right, and can we get these both on the same screen? Alright, where's, yeah, this guy right here. We're just going to cut this, and we're going to paste him right there, because we're in the same file. Much better. So, what we're going to do is we're going to bind this URL parameter to this parameter here on this function. Okay, we'll take a quick look at partial right. It's not a big function. Basically, all we're using is a lambda function, right? And we're using a capture, right? We're using a capture and a lambda function to bind this argument to this function. So this results in an additional function call, right? So we're wrapping it. So we're wrapping our function in another function. That outer function has, through the capture, that variable that we pass to it, bound to it. That way when we call our initial function, it has that capture variable, and then it calls the function that we want to call. I hope I explained that clearly. But this allows us to still use our array reducer, right, which only is taking, right, so the array reduce gets 2 items, right? We have the carry, which is our reduction, right? And we have the item, right? So we're going to get the exception, right? And our carry is the block, right? This is what we're going to be carrying over. So if at any point matcher, this match block exception, returns false, then we've hit the exception and our reduction, right? This is going to return false, which means we return a maybe of false, which means we have no block, right? Now, if we return a maybe of the block, right, meaning if the array reduce returns the original block, right, let's just write it here. If blocked, or if exception hit, right, then we're going to return false, right? Otherwise, we return the block. So now, right, remember we talked about when we originally started this video where we're talking about I like to break things up into their constituent parts, right? So now we're going to write one function that takes, we don't even really care what the block is. Well, I guess we do care. We care what the code is and the URL and stuff, right? So we care about the block, and we take a single exception and we say, oh, is there a match? If there's a match, we return false. Otherwise, we return block. Now, well, this is going to be an issue. We've typecast block to be a block, right? Which means this always needs to return, right? Which means this always needs to take a block. But if we ever return false, right? this is the, right, this is, if you remember, of our array reduce function, the first item is the carry. That's the block, right? This is our first item, which gets passed to the matcher, right, as this. And then each exception gets passed here. And we already bound URL to the function on this line. So if we return false here, that means we get called next with the next iteration of this with false, which is going to get a type signature error here, and it's going to blow up. So, ugh. Now, if we were using PHP 8, we could say block or bool like that. But we're not using PHP 8, so we can't do this union type. Well, I guess we just get rid of that. Derp. Now all we need to do is create this if exception hit function, right? So how do we know if the block matches the exception? Well, if URL equals exception. Oh, this isn't it. This is an actual exception, right? Equals exception URL, then so if the URL that we're blocking on matches our exception block URL list, right? Then well, now we might want to completely ignore. Excuse me. We might want to completely ignore some URLs, and on other URLs, we just want to ignore particular parameters, right? How to tell? How to tell? Right. So there's maybe some parameters we want to always ignore. Okay. Okay, we can do this. We can do this. So if exception parameter is not equal to null, right? And we on the block, let's imagine this was a block. I want to get my type hinting back here, right? And the block parameter triple equals the exception parameter, right? Then we return false. So if the exception has a parameter and a URL, they both need to match. If it has a URL and a parameter and they don't both match, then we're done, right? Else, so in this case, the oh, you know what? Let's go ahead and default these bitches. Parameter equals null, and string equals null. Boom. And code equals 0, right? Yeah. Put some defaults in here. Okay, sweet. So if, and we don't know if we even have a URL, so let's invert this. If exception URL is not equal to a null and the block, right? Oh, no. And this URL is our block. This URL, you can't see me. This URL right here is our blocking URL, right? Or the URL that we're currently doing the block on, right? The testing URL. And the URL we're looking at is equal to the exception URL. Oh, wait. Here's another issue. We're passing in... Ugh. I don't like this. This is getting ugly. We want to explode on the URL, right? And then this is going to give us the host and the URL portion, right? So if parts 1... Ugh. You know, I wish some nice things about C++, right? We could define a using right here and define a const just for this value, just inside this function. Can you do that in PHP? const URL index equals 1. Yeah. Nope. But if I put it here, then it likes it. You can't do it inside a function. What's the actual error? Unexpected const. Dope. Alright, well, hopefully this function doesn't get too much bigger. So, if the exception has a URL, and the URL matches, that URL matches our passed in URL, right? Oh, and then but our exception doesn't have a host, does it? It's just a URL parameter in a code. Okay, let's add a host. It's always something to think about, especially when you're dealing with something that could have any, right, like any possible web server configuration, right? You need to be able to support everything. Okay, here we go. So we have the host now too. Boom, boom, boom. Go back to this code. All right, so let's start at the very beginning. If our parts 0, right, so that's the host, is if our exception, right, so this is the first thing it's most likely to not match, right? So if the exception host is not equal to null and parts 0 is not equal to exception host, then let's just return and not even do anything else. We're going to bail out early. So we're going to return the block, right? Host does not match, right? So now we know if we get to this line that the host, if there is one, does match. So now I can ignore the host stuff, right? Now I can say, does the URL match? Yep, URL matches. Now we look at the parameter, right? So now we say, okay, the parameter, we have a parameter and the parameter is equal. So we have a hit for an exception, so we can return false. Else, we return block. You know what? This is smelling of some recursion here, right? Because what do I really want to do? How do we really want to do this? We really want to say, if we have only a URL, right? Actually, okay. Oh, okay. Here we go. We do it just like this one. All this nested conditional shit, this is bullshit, right? If we have a URL and the URL is not equal to the exception URL, then we return, right? Boom. Now we test parameters, right? Parameters. If we have a parameter and the block parameter is not equal to the URL parameter, we return the block. Last one, this is it, super easy. If we have a code that's not equal to 0 and the blocking code is not equal to the exception code, we return the block. Otherwise, we return false. Boom. Make sure that every non-default parameter matches, right? Okay. Sweet. I love this. You know, I feel like this could be cleaned up with a match expression, but this is PHP 8. We don't have it in PHP 7.1, which I am still targeting. So yeah, now we have a problem. Now we have a problem, right? Because we're passing in this block, but because of the way we're doing an array reduce, and we're passing in, right? This could be either a block or if we have an exception match, it's going to be false, right? So I'm going to have to get rid of the typecasting. Otherwise, it's just not going to work. If we are on PHP 8, we have union types. We could say a block or false, but alas, we're not on PHP 8, so we have to just do this. I really hate returning different return types. But because most PHP functions return false to indicate an error, not null, right? We can't use a nullable block because... Oh, actually, you know what? Oh, actually, I can. Actually, I can. It's been a while since I've done PHP. We're using... my maybe always uses empty to test for falsity. It doesn't have to be triple equal false. Which means... Okay, sweet. So that means this can be a block, a nullable block, and this can return a nullable block. And instead of returning false, we just return a null. Sweet. Okay. So, if... Is PHP 7.1 support... does it support those? PHP... Let's double check. PHP... what is it called? Nullable objects? Nullable function parameter, new features. Oh, I think it's in 7.1. Nullable. I feel like I've been using this. Type declarations for parameters and return values can now be marked as nullable by prefixing them with a question mark. Oh, beautiful. Sweet. Okay. Man, this video I've done, I went actually a lot farther than I was planning to in this video. I'm probably going to wrap this up now. But we have added exceptions to BitFire, which allows us to add exceptions for URL, for specific parameters, specific URLs, specific hosts, and specific error codes, right? And any combination thereof. We did that by adding, these 4 conditionals right here, right? So this takes a single block and a single exception, right? And the URL that it's executing on, right? This is a bound parameter. In fact, we really should pass it. We could pass it right here as 2 different parameters, right? So if I wanted to make this slightly faster, God, I'm awful. Okay, string host, string URL, parts, explode, URL, parts, 0 is the host, parts 1 is the URL. Okay, sweet. And now I can say host and URL. Okay, sweet. So now we remove that temporary variable. We make the code more explicit. And we only do the explode once instead of doing the explode once for every exception. So we have this nice clean block of code here that allows us to have any combination of host, URL, parameter, or code in our exception. And we have now this another function which takes all of our exceptions and a URL that we're trying to block for, and a single block, right? The thing that we matched, we said, hey, should we block this? We're going to use an array reduction function to take that block, and this is going to return either the original block, right? This guy, the original block that we passed in, or it's going to return null. This will return a maybe of null, which means when we call filter block exceptions, okay, when we say filter block exceptions, this gives us back a maybe of either the URL, or this will give us back either a maybe of the block or an empty maybe, right? A false maybe, which we know then we have a match for our exception list. So all we need to do now is, now that we have, originally the first thing we did in this video, processing an Apache input line or an Nginx access log line. We turn that into an object. We're going to run the BitFire. I wonder if I can get it all the way end to end. What time is it? Oh, I've got time. I've got time. We've got time before fajitas get here. Okay, so this video is gonna be so fucking long. I'm gonna have to edit this thing up. So let's look at this guy, right? So we process a line at a time. We're gonna call inspect. Inspect gives us back, right? Inspect is, there's our construction. Inspect gives us, where the hell is inspect? Inspect. Inspect is going to return a maybe, right? Which is, yeah, sweet. Okay, so it's going to return directly in the maybe. So we can now say, oh, this is all coming together. Okay, maybe block, and then from there we can say filter block exceptions, right? So now on the maybe block we can call, this, I should have some type in here. Do, let's say dollar maybe block equals tf maybe block. Can we get some type hinting? Ugh, IntelliFence, what are you doing to me? And then we've got this, I think it's this, whatever this thing is running here. Can we reload this bitch? And it crashed. Nice! Good job, Visual Studio. Oh, hey, there we go. There's an issue with an extension dependency. Alright, let's close that. Maybe block. Oh, come on, IntelliFence, you're killing me. You're killing me, Smalls. I think maybe it's not started up because I can't even control click now. Oh, maybe if I spell maybe right. Oh, well, let's see. Let's go over to our util. Where's our maybe? Okay, so we want to, then create an exception, right? Then, oh God, I don't even have, how can it not pick that up? It's right here. Maybe, it's right there. We're in namespace TF, and I want my maybes. I want my maybes. Maybe. Oh, you know what we need? Boom, boom, boom. Yeah, we have a maybe. Oh, you suck. You suck, IntelliFence. Why is it? Let's see. Maybe a false. Really? Really? I get no help? I get nothing? Let's go to PHP. Oh, how did that get disabled? I wonder if it crashed. Boom, 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 boom. Okay. Nope. Okay, $M. $M. Oh, we got nothing. I got no help. Okay, well, let's see if we can finish this video up even without any help from IntelliFence. So we should say, okay, we create the request, we process and inspect, right? So it's going to inspect on this request that we just set. That's going to return a maybe block. If we have that block, we need to add an exception. So then we say, then, and this is going to take a callable with that block, right? So then we need this needs to turn into, okay, so then we're going to have a maybe exception. I don't like changing types in there, right? So this has a maybe block, right? That maybe object is going to have either false or a block. When we call then, it's going to say, okay, if we have the block, then we're going to do some function. I guess, yeah, you know what? Well, what the hell? What do I care if I convert a block into an exception? So then we're going to call block to exception, right? And then we're going to say, how do I get the value? Oh, we're going to say value, right? Then we're going to say, this is process access file, line at a time. We're going to say exceptions equals array. And then we'll say ex, and we're going to use, oh, I hate this. Oh, I hate that. Oh, no, we're going to, we just return it. Okay, wait. Yeah, I don't need to do that. What am I talking about? I should return it. We already have an empty array, right? I have the line. The array reduction has a, so we're missing the first parameter for this. So exceptions. This is an array of exceptions, and this is a string line. So, okay, so now we're gonna say, ooh, oh, we need to use BitFire, right? Yeah, we need to use, oh, you know what? We could just, you know what I'm saying? Add exceptions. We can just do this. We can just say, now make a new thing that does add exceptions. Right? Well, actually, you know what? I don't want to do that. We don't want to just return those exceptions. Oh, hold on, I got a phone call. Hey.
Hey.
What's up?
Do you want to follow the Mexican place or should I?
I'll call him.
Okay.
Yeah, I'll call him right now.
Okay, well, I'm at the gym in the parking lot. I'm assuming it'll take them a little bit, but...
Okay.